In this lesson, we'll study how Python extends its built-in functionality with external modules, and how your program can access these modules with special import statements. Our hands-on work includes two problems that focus on Python's math module. Yes, we'll use a couple of mathematical formulas in our examples, but don't be intimidated by these. Regardless of your math background, you can still fully understand the core Python-related concepts presented here, which is the main goal. Let's get started. A main reason why we say that Python is a powerful programming language is its extensive support for domain-specific functions in the field of statistics, finance, machine learning, and many others. If all these features were available to your program by default, it would probably take a long time for it to start running due to a long initial setup time. Instead, these features are packaged into external modules, which must be explicitly loaded when your program starts running. A Python module is a set of functions and constants that may be imported from your program, but that are not loaded by default if your program doesn't need to access them. When you need to access functions in a module, you first load that module explicitly with an import statement. In its simplest form, the import statement can be used as shown here. Keyword import followed by a module name. It is in fact common for Python programs to start with a sequence of import statements, where all necessary modules are initially loaded for their functions to become accessible through the rest of the code. In this lesson, we're going to focus on a specific module called the math module. This module is part of the Python standard library, formed of a set of built-in modules shipped with every Python distribution. The math module contains a set of functions that perform complex mathematical operations, such as square roots or trigonometric operations. The module also includes common mathematical constants, such as pi or the Euler's number e. When you want to access a constant defined in an external module, you need to prepend the module name to the identifier representing that constant. For example, constant pi, defined as lowercase pi in the math module, must be referenced from your program as math.pi. The same principle applies if you want to invoke functions defined in the module. For example, function abs, which calculates the absolute value of a number, can be invoked as math.abs, followed by a numeric argument in parentheses. Let's look at some contextualized examples. This simple Python program calculates the area of a circle with radius 5. The program first imports the math module, then it initializes variable radius to a floating point value of 5, calculates the area of the circle as pi times the squared radius, and prints the result. This other simple program asks the user to enter a floating point number and rounds it up to the nearest integer. Again, the program first imports the math module, then reads the user's input, converts it into a float, rounds it up with a ceiling operation available in function ceil in the math module, and prints the result. You can find a PDF document in the material for this lesson with additional information about constants and functions available in the math module. This document can serve you as a quick reference guide for the exercise problems proposed next. The material below also includes a direct link to the official Python documentation for the math module, with comprehensive information about all functions and constants defined in it. If you enjoyed this content, you may watch the rest of this lesson at computersciencecamp.com, linked in the description below. You'll be able to follow along with coding samples and problems in our embedded code editor. Drop your questions in the comment section below, and don't forget to like and subscribe to help support the channel. Thank you, and happy coding!